Awesome. Well, welcome everybody to the September edition. It is my birthday month. I'm definitely have a certain affinity for the month of September. So that'll be coming up here. I have a gift registry on Amazon.com if you're interested in, purchasing any gifts. It's cool. So welcome again to the Indie Pie for September 2023. I'm excited to be here, and I've got a good friend along for the ride too. You'll get to meet him here momentarily, but he and I have known each other for over 20 years. But before we get to that, quick announcements. We are going to actually have another hybrid event this year. It'll be our October meeting. Will be Monday, October 9th. And I'll be presenting alongside with Brad Fruth from Bex Hybrids. And it is our obligatory AI slide. We're actually doing a talk on generative AI and the work we did for Bex Hybrids to build a virtual agronomist chatbot that they've are apparently spreading like wildfire. I don't know. We'll see what happens. It's a cool talk. I did it actually last week at Rally, and it had a really good reception. So come on down if you want, especially if you want to learn about embeddings and what's going on with the various large language models. Should be a good time. And so it will also be available on Zoom. We're going to make sure it's a hybrid event, so you should be able to join us from remote. So folks like David can continue to be one of our number one attendees at IndiePie. Should be a ton of fun. Don't forget in October, so it looks like, the 5th and 6th, we've got DevOps Days Indy. I actually was chatting with JJ Ashgar from IBM, who's one of our Python Web Conference speakers. He will be speaking at the DevOps Days Indy, so check that out. It's a great conference. They typically attract some of the best speakers in the DevOps world, so go and check that out as well. I don't think I'm going to be able to be there. I'll be downtown for that, so maybe we can meet up. But I won't be at the event official. I would love for all of you to also speak at IndiePie. So if you want to pitch your ideas, believe me, the bar is low. Not saying that our current speakers are not high quality, but I would love to get more new speakers speaking here at IndiePie. It's a great way to test a talk that maybe you want to present at a larger conference like PyCon. So submit those to papercall.io/IndiePie. We would love to hear from you. Make sure you join our Slack. We do have a dedicated Slack organization, so you can join with that joiner link there. So bit.ly/join IndiePie Slack, and that'll get you right in. The chat for tonight, typically we don't use the Zoom chat. So if you want to ask your questions, throw those into the general channel. That way folks who aren't necessarily in the meeting can kind of follow along and kind of catch some of the discussion that was happening. And if you want to, ask questions during the presentation, I will make sure I catch those and ask them and follow those on to Kapil. All right. If you are looking for a new career, or if you've got a job opening at your company, we would love to hear about them. Make sure you post those over in the jobs channel on our Slack. Again, the same Slack inviter link there. And then if you're going to live tweet us, make sure you follow at IndiePie. And if you're live tweeting, use the hashtag IndiePie for tonight's event. And so we can continue that discussion on, well, we need to change this slide. It's now X ?
Oh, yeah, that's so true. I haven't committed yet.
You're not committed? We're still on Twitter, still on the Twitter bandwagon. I get it. It's okay. I totally get it.
But I will change it.
Okay, awesome. And I want to thank our sponsors. IndiePie is organized by 6 Feet Up. We make the world a better place by accelerating tech leaders' impact. As a Python and AI for good expert consulting company, we help clients make informed decisions, access accurate data faster, and scale up operations. Our engineers specialize in application development, AI, big data, and cloud technology, and our impactful clients focus on climate action, clean energy, and initiatives that benefit humankind. I'm Calvin Hendricks Parker, and I co-founded 6 Feet Up in 1999 and have been CTO ever since. Thank them for letting us do the cool things we do. I also want to thank our platinum sponsor, JetBrains. If you stick around after the talk, there'll be a higher than likely chance you'll get a JetBrains professional license. We'll do a quick little random drawing, must be present to win. And I also want to thank JFrog. They will also be giving away a PyPortal. Do I have any alternate gifts tonight from them? Nope, it'll just be a PyPortal. So an Adafruit PyPortal. So if you like hacking on cool little embeddable devices, you can grab one of those tonight as well. If you want to be a fabulous sponsor of the IndiePie gang, make sure you go to indiepie.org/become a sponsor, or email myself or Laura at 6feetup.com, and we'll make you a sponsor, and you can give away fabulous prizes as well. All right, that all said, I'm super excited to introduce a friend of mine. We were just talking earlier. that we've known each other for 20 years, probably this year, I think. And I'm excited because he's working on a really cool open source project that we've been involved with and still going for many years now. So I'll turn this over to Kapil and unshare my screen.
Well, thank you for that intro, and I'll see if I can share my screen. Let's see. Okay, hopefully that works. And I've also joined the IndiePod channel, and appreciate Laura and Calvin for if you guys all could relay any messages. So, hi,
Yay.
my name is Kapil. I have been using Python since the late 90s. I feel like it's a safe space to say something like that. And also doing open source since about the same time. I've been doing public cloud since App Engine was the original serverless and before EC2 instances had persistent disk. I am currently co-founder and CTO at a startup around that was built on top of Cloud Custodian. And I'm also a creator and lead maintainer of Cloud Custodian. Cloud Custodian is a project that I created when I was at Capital One, as they were making their journey into the cloud. And there was a lot of things that they had to deal with in terms of compliance and security and things. And I realized the things that were sort of making developers less productive was sort of waiting for the compliance and security and other groups to be able to make sure that something was ready for them to be used. And so Cloud Custodian sort of got born out of something as simple as tag management and kept going. The sort of key for it was being able to actually fix problems. There is a load of tools that will report on problems. I call it admiring the problem as opposed to fixing the problem. And Custodian was built around the idea of let's fix the problem. Let's fix the problem in real time. Let's let's integrate with all the native features of the cloud and be the easiest way to take advantage of them for managing the fleet at scale. So it is now in the Cloud Native Compute Foundation as an incubating project, and it supports multiple cloud providers from AWS, Azure, GCP, Kubernetes, and Terraform, which is more of a little bit different, and Oracle. On the Terraform side, it's also about applying these policies to your infrastructure as code, pre-deployment, even pre-commit, pre-merge. And then the rest is sort of what's actually in your footprint. And at a certain scale, I think the realization was that the problem's too big to fit in anyone's head. Like if you can't keep your entire footprint of cloud infrastructure in one person's head or one team's head, then you're probably at a place where something like Cloud Custodian can benefit you. What is it underneath the hood? Well, it's sort of governance as code. It's a YAML DSL for policies based on querying resources, finding an interesting set of things and taking actions on them. And sort of best in class in actually modifying resources and doing remediation. And the intent, as I said, based on its origins, is that it scales to enterprise needs, but it also scales down to a mom and pop shop or a one team's needs within a larger org. So the overarching goals are sort of driving behavior change, and that's really about being able to tell people as they're doing something wrong, if they did something wrong, especially in larger organizations. One of the hardest problems is actually for people to actually know what the right policy is, what the current policy is. I mean, I remember changing the tag policy within an enterprise and spending the next 2 years explaining what the tag policy was. And people were like, is that new? And so being able to actually tell people about that in real time as they do something wrong is a huge win from helping people be compliant from the start and also just communicating things out within an org. And then driving compliance, like making things better out of the box and if you can fix a problem, it's worth 10 of reporting a problem. because reporting a problem means going up an org chart, going back down a different org chart, and actually to get to actually fixing a problem. Whereas if you can fix a problem and tell people about it in real time, or you can drive workflow around that, that's a huge way to just help people actually get to a better place. And then driving cost savings. For sure, like cloud's great. Like you can spin up a lot of things, and cloud's not great from a cost savings perspective because you can spin up lots of things and forget about them. And that is one of the ways that the project can help people. All right, so open source, I already said we're in CNCF. We're in the 100 million download club, 400 contributors, lots of pull requests, lots of tests, all in Python. Well, sorry, 95% in Python. We have some stuff in other languages, but and we cover off on lots of different providers, and providers beyond the ones I mentioned: AWS, Azure, GCP, Oracle, Tencent Cloud, Kubernetes, OpenStack is there. Yeah, we try to do the long tails, but a lot of that's based on what the providers or users are interested in and want to contribute to. So what does this YAML DSL look like? Because I've seen all kinds of YAML DSLs, and some of them are like programming in YAML. We try not to do that. We try to be declarative. We try to be reasonable from like what we really strongly believe in is making it readable. Like a lot of what we've replaced is mostly one-off scripts that organizations have done that have no monitoring, no operations, etc. So what we're trying to do is be declarative and readable so that not only the people that wrote the policy, but the developers that are beholden to that policy, or the auditors, or the different teams. Like I think in general, when we end up as developers reading more code than we write, and making it readable is hugely important. I think that's why we're at a Python user group meetup, maybe. And so from a policy perspective, on the screen here, we've got a policy define unused EBS volumes. And we first define a resource. Then we define an execution mode, which we can go into later. And then we then define a set of filters, which is basically saying, hey, of all the EBS volumes in this environment, what are the interesting set of things? And we can do arbitrary filters here. We can do nested Boolean and ors. We can do lookups that involve API calls, additional hops from this. We can do natural attribute lookups, which is most of what this is right here. And then we can take a set of actions. And we have a set of generic actions, and then we have a set of actions that apply to specific resources. It could be, resize the EBS volume, or modify it to use a different EBS volume type. A lot of the examples here are a little bit AWS specific, but most they all generally carry over to other providers, and we've got a few others here that are not specific. So given we have a set of in terms of filtering on these resources and this arbitrary filtering, it's one of the workhorses for this is what we call the value filter. And this allows for, we use a expression language instead of, like you may be familiar with JQ, we use a language called JMES path, which is built into the AWS CLI. It's also built into the Azure CLI and is effectively another sort of JSON query language structure. Sorry, scam likely. I'm not going to answer. And this allows us to do all kinds of things. So we can do value comparisons. We can do data conversions into different types. So we can convert something to a sitter. We can look up values from external data sources. And not like some of that's JMES path. The key expressions here are from JMES path, but some of the additional capabilities here are sort of what we built in to be generally applicable and useful. Like, hey, I want to make sure that all my tags are valid from my vocabulary, and look that value up from a URL. All right, let's keep going. When you use Custodian, it is stateless. Like, it is intended to be operationally robust and simple to use, but it also is intended to feel like a native application in each of these clouds. So whether or not whether or not your log outputs or blob storage is going to for outputs is all going to your native whatever cloud provider you're using, that's where the outputs are going. So you might have metrics into Azure, into GCP, into AWS, and that's all sort of the intent is that if you're already using that provider, that running Custodian that provider very much is putting the outputs in the places that you expect, so that it feels natural and native. So what can we do with it? We can do lots of things. I mean, we have a vocabulary of filters and actions that numbers into the thousands as well as resources, but we can also sort of chain together with these policies that might be composed of filters and actions to create workflows. So in this case, on the left, we've got like a statement. Let's find these poorly tagged instances, and let's stop them in a day and then terminate them 3 days later. And we do this chain together with this notion of mark for op or marked for op action filter to be able to store state for just the next workflow to be able to pick up. And that state, that stateless, is actually stored on the resource itself in the form of tags. So architecture diagram. Yeah, so you got the CLI, basically what we start with. You got policy execution. We support this notion of event-based execution mode. So Custodian underneath the hood has like a serverless provisioning framework, because what we actually do is we will, if you say you want to respond to a particular event in the cloud, we hook up to whatever that cloud provider's notion of a state change or an API change, API call in that provider is, and we actually will create a serverless function in that. And this works against AWS, Azure, GCP, to actually create a serverless function in those different providers. So you say, hey, I've got policy. Whenever you launch a VM, I want to double check that it's encrypted, that it doesn't have secrets and user data, et cetera, et cetera. And this will actually provision the serverless function, the event source, and hook it all together, as well as being able to drop the applets. We also, for super busy environments, we also support different ways of actually querying those resources. The default way is just sort of using the underlying service of that particular resource type. So in GCP for a VM, it would be the compute service, but we also support going to the native cloud asset inventory, let's say, of the providers. In that case, for GCP, it'd be cloud asset inventory. In Azure, it'd be resource graph, and AWS would be AWS config to query those sources out. And then the outputs, as was already outlined, are to the native stores. We generally have about 4 different types of outputs that we consider. One is policy execution tracing, one is metrics, one is object storage, and one is logs. Tools of mass operation are tools of mass destruction. So we also have built-in safety belts. Like the dirty secret of cloud, it takes one bad shell script in Jenkins to have a bad day. It doesn't have to actually modify anything. You can just be in a hot loop and do a DDoS on the API. So Custodian itself has built-in safety belts from a modification perspective on resources. And that is being able to say, hey, if you target more than a certain number of resources, don't do that. And we stop. So as an example of sort of that event-based mode, here is a policy against RDS that basically says, hey, anytime somebody launches an instance, if it's not encrypted and or it is publicly available, go ahead and delete it. The P99 for this type of thing is a few seconds. So this is generally like that ability to modify and change things and respond to, like, effectively you can think of the policies as evaluating on the API calls, and being able to make sure that the changes and modifications that are being made to the environment are compliant to the organization's policies. We also support AWS config rules. Like I think we're like this is a 20x line of reduction over trying to use a custom config rule because we have provisioning built in, versus like what that looks like with the native capability, or doing it the way that is otherwise documented. We can also respond to guard duty events, like here's something that's saying, hey, well, this is actually in a centralized environment, like being a centralized account across a delegated administrator for guard duty, and being able to say, hey, anytime I get an event that is a high severity, that maybe I do some additional filtering here to make sure it's something I actually trust or care about, go ahead and change the instance profile to null, hibernate the disk of the instance, snapshot the disk, like set it up for forensics, let's say. And that is really about like being able to, generally speaking, being able to respond to both event-based things as well as being able to evaluate whole fleets as sort of across the entire population is one of our goals. Doing the same thing in GCP. Well, let's say we've got an instance that's being started and at a quarantine tag. This is a particularly contrived example. GCP tends to be, I say 800 milliseconds here, but it's probably like 300 milliseconds. So like like the notion of real time here tends to vary by provider and what the provider natively supports. Like I said, AWS is, I think P99 is probably around 30 seconds. GCP is milliseconds. Azure's a minute or two, let's say.
I was gonna ask a question about that. How have you seen the P99s change over time since you've been doing this now for years?
So Custodian came out originally in 2016. So yeah, we've got support for the provider. I think we had AWS Azure GCP by like 2019. GCP, I mean, honestly, they haven't changed that much, to be honest. That's actually like AWS has gotten a little bit faster. GCP was always pretty good. Azure has gotten better, partly because they started to use the Azure console actually started to use the resource graph stuff, but there's still, things that can be eventually consistent, let's say.
Yeah, there's one more question from David about how does it prevent commands from running? You mentioned kind of the safety belt, and kind of follow on with
we're not trying to prevent commands from running because we don't want to be inline as a tool. Any tool, I think, can't be inline between a client and the cloud provider API's surface area. A, because it's very big, and B, because it's very high volume. If you talk about object storage volume, like, I mean, I've done hundreds of thousands of requests a second against object storage, and like that's not a place you generally want to be from an enforcement perspective. So what we do instead is that we listen to those API calls and are responding to them in real time. From a prevention perspective, we do support that, but that's against your infrastructure as code assets, and there'll be an example of that in one moment. Sorry, same thing against Azure. Anytime you're creating a key vault or modifying a key vault that doesn't have a creator tag, go ahead and auto tag that based on the modifying user within the API event to go ahead and make sure that tag exists. So a lot of this is about, like I said earlier, it's about driving behavior change. And the biggest part about driving behavior change is actually sending information to humans about what's going on with the things that they own. And so the C7i mailer is an additional tool that we distribute that is effectively receives the event streams, the notify action from policies, and actually figures out how to deliver it to an end user. Be that a Slack channel, Splunk as a data integration, etc. And so This will do like the grouping and aggregation of the resources by particular users, do the address lookup, do the resolution on that. This is all driven by the most important tag that you can have on a resource, which is who's responsible for it, who owns it. Because without that, it's hard to know where to send it to. Yes, you can have fallbacks by account and other things, but like if you're multi-tenant and or if multiple people can create things across multiple domains within business teams within a particular cloud provider, then you potentially need to be able to go smaller than that. But this entire reason for this presentation, or the reason d'entrée, was to talk about some of the cost savings that you can do with Custodian. Because yes, there's millions of things you can do Custodian, like we do security, operations, governance, all kinds of stuff. But cost savings is, I think, meaningful to folks as we all strive for better efficiency in around our cloud, or look at potentially exiting back to a data center. So looking at the cost savings in general, we can look at a couple different categories of things. So tag management, as I just said, from an ownership perspective, is useful to actually know who owns something, but it's also typically the basis for most of the chargeback within a given system. That tends to vary a little bit by cloud provider, but ignoring that for the moment, I think it still seems to be very fundamental across providers. The other class of things is garbage collection. Like, hey, I put up a database that hasn't had any connection for 2 weeks, like literally the definition of unused. Or I have an unattached volume or disk, like that's not attached, like literally not being used. So going out and collecting the garbage. Lifecycle management can go across a couple different set of areas. I've got slides on each of these, so I'll probably walk through them. But this is generally how I categorize sort of where Custodian can actually help folks across a broad swath of use cases. The one thing that we don't do, because again, stateless, all this is stateless, is doing like RI management or stuff like that, which is there are a bunch of commercial tools that I'm sure people can use for that purpose. So back to the original thing on tag management, and knowing the most important thing you can know is who to contact when something's not like in a good state. And we have abilities to auto tag resources by being in the event stream, listening to the events from the API about who created something and how it got modified, and being able to directly modify the resource with who actually created it, who actually modified it. We have a boatload of tag related capabilities from, as noted here, from being able to make sure that the value for the app tag corresponds to the vocabulary of apps or environments, et cetera, as well as normalizing things, fixing typos, et cetera. Garbage collection is there's no shortage of garbage that gets created per se in the cloud. That could be, really old snapshots, unused instances, it really is just a plethora of things. And I mentioned an example of, sorry, my dog just joined, of taking a database that has had no connections for the last 2 weeks, which is an example on the right, and then marking it to be stopped in 2 weeks. And generally speaking, when you're going to take a modification, or if you're going to modify or delete something, you want to notify somebody. That's generally a good practice. There's a set of what you can do, and a set of what is good to do within your organization. And some degree of that is making sure that you communicate before you do those things, as well as or have that policy go into effect. But literally, a database that has no connections is literally the definition of the unused. And so in this case, we're going to mark it to be deleted, and then if we had space on the screen, we would notify somebody, hey, that's not doing anything.
Yeah, we had
going
a
on
we had a,
to-
we had a recent example of that where when you're building AMIs, it uses a EBS volume,
Mhm.
but there's nothing that automatically deletes that EBS volume after the AMI has like been put in place. We had, I mean, it must have been 1,400 EBS volumes that had stacked up, costing about $700 a month.
I don't know if anyone's old enough for that movie, Remo Williams. Automation is fast and you to your grave. But the line from Remo Williams is fast food. But yes, yes, I firmly believe it. Like Cloud Custodian is, I've seen it help organizations save significant amounts. Let's say just by cleaning up things that were problematic. I mean, lifecycle could be like lifecycle is a great example. Like just cleaning up multi-part upload, like incomplete multi-part uploads. It could be like archiving old images in a registry. You can set up like Terminator lifecycles where you're like, hey, in development environments, you can have an instance, but it only lasts 30 days, and then we're going to get rid of it because otherwise you probably forgot about it anyways. And there's sort of all kinds of things along those lines. And this one I've got two. One's like around GCP and one's around an ACR registry, just be able to set up expiration things around them. These are more filtering just because yes, custodian can also apply the life cycles and do the modifications, but what was the phrase? The brevity of the margins no longer allows me to present the full proof. You can also like just do online resizing. Some things require like resizing instance typically requires offline resizing where you have to actually turn it off and then resize it, and we support that. We can do that, by the way. Like, but there's also some set of things that allow for online resizing. So in this case, I'm looking at things that are in AWS that are IO1 volumes that are like not really using all the capacity that they've been allocated, and saying, okay, let's go ahead and modify it to something else that has additional burst capacity and also likely saving a boatload as well. This is a shift left example to the question that was earlier. So we also support doing policies against your infrastructure as code. This is slightly different. Like we have a separate CLI front end called C7 left, and this is intended to be on developer workstation, in your CI pipeline, or in your CD pipeline. And so we're doing more static analysis. But well, static's not quite there because we actually will interpolate Terraform. We actually embed Terraform because it's the only, sorry, we don't embed Terraform. We embed, because Terraform is no longer open source, but we embed NPL libraries from HashiCorp to be able to interpolate Terraform with high fidelity. In this case, HCL2. But the general notion here is being able to do policies that are pre-deployment as opposed to, and that requires being able to evaluate using this as a CI check, let's say. And in the context of CI, we actually integrate natively with the CI providers to be able to try to help the code reviewers. So GitHub, this will directly annotate the PR, GitLab, etc., so that we're helping folks actually that are reviewing actually get to the right place with regards to understanding what the problem is. Sorry, I've got a dog here that's like very insistent. Okay. Hold on a second. I'm going to pause for a second and just okay, she left. All right, good to go. So off hours is another great thing because like if you think about it, like 2/3, if we count weekends, of our time is like not per se working. Like 7 times 24, track 40 hours. there's still a lot more hours out there. And if we're not using all that stuff that we're provisioning in a development environment or a QA environment, let's turn it off. Let's be green. Let's be energy efficient. Let's be cost efficient. And we can do that across lots of different things. Again, sorry, this is a AWS specific original content, but this applies to GCP and Azure as well. And in AWS, you can do that on EC2, auto-scaling groups, RDS, across the family of different computes engines that are available for RDS, and just turn off. And you can do that on a basis that allows for development teams across multiple time zones to specify which time zone they're in. You can do additional things like, hey, I'm still working on this, and like they apply a tag to the resource and it basically turns back on, or doesn't go through off hours. So lots of different flexibility. Oh, and I've come to my security portion. Yes, that is an eyesore. It's called an eye chart of from 5 years ago on what security might actually look like in AWS. But I think it's only gotten more complex since then. So, but I've got a bunch more slides on security stuff. Happy to go through that, but maybe I should just pause and take a look if there's any other questions. But or we can just take a break.
Yeah, I think we're up to date on questions. Anybody have any current questions they'd want for Kapil? Awesome.
Well, then I'll take a pause there.
Hi, I got one. So how do you prevent the command from being executed? If I'm on the CRI in my machine, it will run, right? You need some kind of CI to prevent it?
So we have two different operational modes. Our bread and butter is actually listening to the API audit trail of the cloud. So the two predominant modes for custodian are either polling and querying the entire fleet, or being event-based in real time. And the event-based real time, we're actually listening to the API trail for the cloud and provisioning a serverless compute to subscribe to those API events that are of interest. And so that's not prevent, that's actually real-time remediation. But it's sort of like if I launched a database, but it never got stood up or never had a connection, did it actually exist? Or same thing with an instance. Flip side is we also have a capability around doing true preventative, and with being able to write these policies directly against your infrastructure's code assets and evaluating them directly. But that tends to require being able to be integrated with the CI pipeline, whereas the other mode doesn't require any integration with individual app teams. It can be done centrally from as a directly against the cloud provider account. Does that answer your question?
Yes, thank you.
Awesome. So no one else is in the room wasting money on AWS?
Or GCP or Azure,
Yeah.
public cloud. Haven't all go back to the data center yet. Pay the VMware instead.
No, wait. VMware by default was burning money. Awesome. But I think we're good to continue.
Well, that's all I really had for my presentation. I could go with the security stuff. I got some backup slides, but I mean, I don't want to just keep talking like per se of get tired of the sound of my own voice. Let me rephrase. So
obviously there's the question of like, if you want to track stats, like trending metrics across your like infrastructure, like if I want to know, items in a bucket, or be able to see where resource usage is happening over a longer period of time. Because it seems like being stateless, Custodian gives me that point in time whenever I run it, details about like my infrastructure or reports. What do people typically do in that case when they want to track things over time?
So the notion of track, like just because it's stateless doesn't mean it doesn't have access to state. The state that has access to is the provider. What's available to you in the cloud APIs. So if I wanted to look at state over time, I'd probably look at a metrics store or metrics filter, because now I can actually say, hey, is this being used? Like, what's the growth over time, like against the metrics against a given resource? And so you're able to do multiple intersections. On the filtering side, you can do multiple intersections. Like I can go from, hey, show me all of the Lambdas that have had API calls in the last 30 days that also have an IAM role attached to them that also allows them to create users. Like you can do that sort of arbitrary logic and filtering to go multi-hop on both state from a metric store as well as access from an IAM perspective.
Yeah, so leveraging that cloud, whatever cloud provider you're on first for that before you go off and build your own storage of that kind of information.
I mean, the cloud provider already has it. It's about giving you an expressive language that allows you to express your policy, and while still taking advantage of what's native state stores.
Yeah, I thought it was interesting. You now support config rules. I don't think I've used those yet.
Well, that's been around since like 2017, 2018. Anyways, yeah.
Well, I've never used it. We never used the config rules. I always just used custodian.
Yeah, I mean, yeah, we definitely had a very large, very prolific contributor realize that, hey, they were doing a bunch of stuff with config rules. And like, we don't actually need to use this, do we? Yeah. Yeah.
Cool.
Well, I hope that was fun. Hope you all, if you're using the cloud, check out the project. Again, we've got about 1,000 people in Slack. We're all friendly, so generally try to do Python community rules of conduct. Although technically we're under CNCF code of conduct. Yeah.
That's awesome. Well, thank you, Kapil, for joining us here at IndiePy this month, and a huge round of applause. Thank you so much again for being with us.